Welcome back, dear students. So let's continue with the limits as definite integrals as the limit of a sum. So today I'll be taking this particular problem. Okay, so integral is from 0 to 3 e to the power 3x dx. Okay, so let's solve it in a usual manner. So you know the integral of e to the power 3x will be 1 by 3 e to the power 3x, right? But we have got the limits with us, so we'll put the lower limit and upper limit. So when you simplify or when you substitute the value of x by the limits, you have 3 into 3 minus e to the power 3 into 0. Alright, so this is 1 by 3. So e to the power 3 into 3 is e to the power 9 minus e to the power 3 into 0 is 0, that is e to the power 0, right? And you know that anything to the power 0 will always be equals to 1. So please make a note of your answer. Now let's see the solution of this using the definite integral as the limit of a sum. Okay, so here we have, okay, so as usual we have, okay, so lower limit a is 0, upper limit b is 3, and the function, okay, this is my function, so fx is given to be e to the power 3x, right? Now in that formula we have h, right? So we have h is equals to b minus a, that is 3 minus 0 divided by n, which is 3 by n. Okay, right? So we have fx also, but in the formula we have f of a plus rh, right? So a plus rh is there. So we have f of a is 0, r into h is 3 by n, right? So h is 3 by n. So how much is this? This is f of 3r by n, isn't it? Right? Okay. Now if fx is this much, that is in place of x we have this one. So that's why this becomes e to the power 3x, but in place of x we'll write 3r by n. So how much is this? This is equals to e to the power 9r by n. That means the value of this is e to the power 9r by n. Okay, so therefore your integral I will be equals to, so this integral will be equals to limit n tends to infinity h, right? H is 3 by n, summation r is from 0 to n minus 1, f of a plus rh, which is e to the power 9n by r. Okay, now if you see here carefully, can I write this as, okay, let me write it here. So limit n tends to infinity 3 by n. Okay, so we have r is from 0 to n minus 1. So can I write this as e to the power 9 by n whole to the power r? Yes, so I just want to substitute the value of r, you know that, so that's why I'm keeping r in separate manner. Okay, now let's substitute the value of r. Okay, so we have limit n tends to infinity, so you have this 3, this can be taken outside, so we have 1 by n, right? So the first value for r is 0, so it becomes e to the power 9 by n to the power 0 plus we have e to the power 9 by n, next value for r is 1, so it becomes 1, plus next becomes e to the power 9 by n to the power 2, and it continues, right? It continues, and the last value becomes e to the power 9 by n. What is the last value for r? The last value for r is n minus 1, right? Right. So this is what my expansion look like. Okay, now see, you have one more formula that you noted down earlier. Okay, so let me show you the formula. So I'm talking about this particular formula. Okay, formula number 4. So basically this is a formula of GP. All of you must be remembering this. Okay, so this is the formula of GP. So here formula says A plus, so remember this is your first term of the GP, this is your second term, this is your third term, and this is your nth term. Okay, so A stands for the first term, remember A stands for the first term. Okay, so we have got this formula, and let's check whether these numbers are also in AP or not. Okay, so first and foremost, let me simplify this even more. So we have limit n tends to infinity 1 by n. Now all of you know anything to the power 0 is 1, right? Plus we have this thing. Okay, so can I write this as 1 into e to the power 9 by n whole to the power 1? Similarly, I'll write this as 1 into e to the power 9 by n whole square, and it continues, and let me write here 1 into e to the power 9 by n whole to the power n minus 1. Okay, right. Now if you see here, the first term is A, right? First term is A. So if this is your A, this is also A. Now if this is your R, then this becomes R to the power 1, which is R. Now this is A. Now you know this is R, so this becomes R square. Similarly, this is your A, and this becomes A to the, this is your R. E to the power 9 by n is R, and you have power is n minus 1, right? Now just check whether we can apply that particular formula or not. We have A plus AR plus AR square till AR to the power n minus 1. Yes, so that means we will be able to apply that particular formula. Okay, so this becomes 3 limit n tends to infinity 1 by n. So formula says the sum of this is A is 1 into R to the power n, right? So R is e to the power 9 by n. Okay, so R to the power n minus 1 whole divided by R minus 1, that is e to the power 9 by n minus 1. Okay, so that's what we get. Okay, so I don't have space here. You may pause the video and note down till here. Okay, right. So let's move to next page now. So here we have, see here very carefully, we have something is getting cancelled, I guess. See, this and this gets cancelled. Yes or no? So we have, this is equal to, so we have 3 limit n tends to infinity 1 by n. So into, we have in the numerator e to the power 9 minus 1. So in the denominator we have e to the power 9 by n minus 1. Okay, right. So you have, see, this part is a constant thing. We don't have any n, right? So we can take it outside, right? So this becomes 3 into e to the power 9 minus 1. Okay, so we have, see here carefully, limit n tends to infinity 1 by n into 1 by, so see, this everything came out, so we have 1 left here, so we have in the denominator e to the power 9 by n minus 1. Okay, so what will I do here is I'll do some substitution. We have, okay, so here I'll take n to be equals to, okay, so n to be equals to 1 by x. Okay, so if I take n to be 1 by x, then what will be x? X becomes 1 by n, isn't it? And as n is becoming infinity, as n tends to infinity, obviously the value of x goes to 0. So that's why I'll write x tends to 0. Okay, and 1 by n is x, right? So it becomes x into 1 by, see here carefully, this becomes e to the power 9 by n can be written as 9x, isn't it? We have minus 1. Okay, now see, what am I going to do here is, now I'll bring this x to the denominator, and I'll bring this limit also to the denominator. Okay, so if I do that, then we get, so we have 3 into e to the power 9 minus 1. Okay, so we get 1 by limit x tends to 0. So we have e to the power 9x minus 1. So we have this x goes to denominator. Okay, now there is a formula, there is a formula from class 11 limit which said limit x tends to 0 e to the power x minus 1 divided by x is always equal to 1, right? So this is the formula that is available. But here, see, if you have x here, then you must have x here as well. But here we have 9x and we have just x here. So we will try to balance this. We'll put 9 here, and in order to balance, I'll put 9 here. Okay, so this 9 comes outside, so it becomes 3 by 9 e to the power 9 minus 1. So we have, how much is this now? So is this there in this formula? Yes, right? So this becomes 1. So this is 1 by 1 now. Okay, so how much is this? This is exactly this, and this gets cancelled, right? So this becomes 1 by 3 into e to the power 9 minus 1. Yes, so in the beginning that I showed you that this was our answer. Okay, so this is how we need to do the sum. Okay, so only thing is here you need to practice. You need to practice a lot in order to get familiarized with this kind of sum. Okay, so with this we close for the day. Okay, and in the next class we'll be learning the properties of definite integrals. Okay, and one more thing I want to say here is you can refer your textbook for further solutions in your solved examples, right? So with this we close. Thank you very much.